Hey guys, welcome. This is 3.4. So this is about present value of annuity and amortization. So this is about having a present amount, meaning you have bought a house or you have bought a car, and what payments would you need to make to pay it off, or how long would it take you to pay it off, or maybe you're receiving payments from some type of life insurance policy you bought, and we want to know what the original amount was. So this is what amortization is. We want to know how long will it take to pay the account off. The last section, 3.3, was future value. We wanted to know how much we would have in the future. We would put payments in and we would have X amount of money in the future. So this one's opposite. We're given a chunk of change that we have to pay off, unfortunately, right? Okay, so down here are your amortization formulas. So it's present value equals payment times 1 minus 1 plus I to the negative n over I, where everything's still the same. I is still rate over compoundings, right? So I'll write that in somewhere. So I is still rate over compoundings, and n is still compoundings times time. So all that remains the same. Okay, perfect. And then the next two are just rearranged for you. Let me see, I didn't want to do that. Where's my undo? Let's see. Did it change anything? I don't think so. Okay, cool. All right. And then over here, I want to be on view. There we go. They're rearranged. If you need to solve for payment, payment equals present value times I over 1 minus 1 plus I to the negative n. If you need to solve for n equals the natural log of payment minus natural log of payment minus present value times I over the natural log of 1 plus I. Okay, and of course, knowing the formulas, knowing the problem will tell you what formula you should use. So the first three are just practice problems, getting to work with the formulas and typing them in your calculator. So we can get started with that. Okay, so for example 1, we're given n is 40, I is 0.01, payments 400, what's the present value? This means that we'll use the first formula. So that's the one we're gonna use. Okay, so set it up. We're given that our present value is going to be equal to our payment of 400 times 1 minus 1 plus your I value of 0.01 raised to the negative value of n, negative n. And all of this is over your I value, which is 0.01. Okay, now let's type that in the calculator. Ugh. All right, so 400 times fraction 1 minus parentheses 1 plus 0.01 becomes 1.01 raised to the negative 40. And just for your sake, put parentheses on it. It's good habit building, right? There you go. Over I, which is 0.01. Enter. We get 13,133.87. Maybe if you round, that could be 8. There you go. That's how you do it in your calculator. Okay, and again, let's say you didn't have those fancy buttons, those fraction buttons. Oh boy. You would type it in as 400. Actually, what would I do? I think I would do parentheses 400 times 1 minus parentheses 1.01 raised to the negative 40, close that. That's everything in the numerator. Over parentheses 0.01. There you go. Brutal, I know. Okay, let's try another one. All right, 2. This one says present value is 14,000, N is 72, I is 0.005. What is the payment? So this means we'll be using the second formula from the above. All right, let's see, there we go. Okay, so set it up, and we get payment. We get payment is equal to the present value of 14,000 times I, which is 0.005 over 1 minus 1 plus 0.005 raised to the negative 72. Okay. Now let's type that in the calculator. Okay. So for 14,000 times fraction button 0.005 over 1 minus parentheses 1.005 raised to the negative 72. There we go. Hit enter, and we get 232.02. All right. Now, there's that. Not bad. That's how you work the formulas. And that's how you type them in. Now, example 3. Present value is 20,000. I is 0.0175. Payments 500. We are looking for N. Oof. All right. So I'm going to write that down here before we get started. All right. Give me 1 second. N equals the natural log of payment minus the natural log of payment minus present value times I, all over the natural log of 1 plus I. Okay, perfect. Okay, so there it is. Now let's plug in what we know. N equals the natural log of the payment, which is 500, minus the natural log of the payment, which is 500, minus the present value of 20,000 times I, 0.0175. And all of this is over the natural log of 1 plus I, 0.0175. Okay, let's type it in our calculator. So on the left, fraction, natural log 500 minus natural log 500 minus 20,000 times 0.0175 over natural log 1.0175. Okay, enter. And we get basically 69.4. Round that up. So put 69.40. And there we go. That's how we work our formulas. Now we'll get into word problems, and we will have to figure out what formula to use based on the actual problem. Okay, so let's do it. All right, I need to zoom in a bit here. Let's see. Work with me, work with me. There we go. Okay, let me take a quick pause for a second. Okay. American General offers a 7-year ordinary annuity with a guarantee rate of 6.35% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $10,000 annually over the 7-year period? Okay, so this is kind of like, what is it? Like a life insurance thing. Like you'll pay one big lump sum, and once you pay that lump sum, you'll let it sit there. And I guess when you're ready to take it out, or when they're ready to pay you out, you will start getting payments of whatever amount that your lump sum has earned. So this is what this question's about. So it all may seem confusing, right? All right. But here it says, how much did you pay for one of these annuities if you are receiving payments? So this means it wants to know what is the present value. If we want to receive $10,000 payments over a 7-year period, it wants to know how much money are we going to put in. So this means that we are using the present value formula. Okay, so with that being said, let's go look at it again. I'll write it down below while we're looking at it. So PV equals payment times 1 minus 1 plus I to the negative n over I. Okay, got it down. And there it is. So let's label everything we have. So for this one, payment is $10,000. Let's see, I, which is rate over compoundings, right? Let me move my box out of the way. There we go. Okay. I, which is rate out of over compoundings, we are getting a rate of 6.35%. So 0.0635. And we are compounding annually. So annually means 1. So this just becomes 0.0635. Okay. And then N is compoundings times time. Well, we are compounding annually, which is 1, and we're doing this for 7 years. So we get 7. Okay. Take all of this and plug it into the formula. So PV equals 10,000 times, let me move over, 1 minus, you can see it like that. There we go. 1 minus 1 plus I, so 1 plus 0.0635 raised to the negative 7 all over I, which is 0.0635. 0.0635. All right, which means our present value. So in order to receive these $10,000 payments, we must purchase this annuity for, let's see, 1 minus, that just becomes 1.0635 raised to the negative 7 over 0.0635. All right. And enter. We must put in $55,135.98. So that's how much we should pay for one of these annuities. Yeah, because I had life, what is it? I had life insurance. I think it was whole life insurance. I forget. It's like an index fund. And the guy wanted me automatically to put in, I think, around $25,000, like right off the bat, to make money later on like this. And I was like, no, I'm okay. I was like, I can give you like monthly payments, but even that I wasn't down for. The only cool thing about, I think it's whole life, is that your money is getting interest and it's indexed, which means if the stock market crashes, your money doesn't go anywhere. Your money stays the same. That's the cool thing. But there are fees to it as well. So sometimes the fees on whole life insurance can outweigh the actual investments you're making. So it is something to look into, but I think we're better off with like a mutual fund and stuff. Unless you're on the brink of death, yes, get life insurance so your family gets paid. Or if you don't like your family, pay your cat. Okay, moving on. All right, so example 5. E-Loan offers a 36-month auto loan at 9.84% compounded monthly to applicants with fair credit ratings. If you have a fair credit rating and can afford monthly payments of $350, how much can you borrow from E-Loan, and what is the total interest you will pay for this loan? Okay, so again, this will be present value. Okay, because we want to know how much can we borrow if we can afford $350 payments. So again, present value. All right, so that's the same formula above. I guess might as well write it down so we get used to it. PV equals payment times 1 minus 1 plus I to the negative n over I, right? Payment times 1 minus 1 plus I to the negative n over I. Label everything we have. All right, do this in green. First off, our payment. We can afford $350. My interest is rate over compoundings, so 9.84% compounded monthly, so 0.0984 over 12. Okay, I doubt that's a nice number. 0.0984 over 12. Oh, it is. Nice. 0.0082. Perfect. Okay. And then go for n. N is compoundings times time. We are compounding monthly. And we're doing this for 36 months. So actually, it's already giving us n, if you think about it, because 36 months is how many years? 36 months is 3 years. So We're compounding monthly for 3 years. That's 36. So this one already gave it to us. Not bad. Okay, we have everything we need. Take this information and plug it into the formula. So PV equals 350 times 1 minus 1 plus 0.0082 raised to the negative 36 all over 0.0082. Okay. Now, let's see how much we can borrow. All right, clear this out. 350 times fraction 1 minus, that becomes 1.0082 raised to the negative 36 over 0.0082. We can borrow $10,872.23. Okay. What is the total interest you'll pay for this loan? Okay. So down below, we'll just say interest. So we are making $350 payments for 36 months. So that would be 350 times 36. 350 times 36. So for this loan we can borrow, we'll actually end up paying back $12,600, which means if you subtract the original loan amount of $10,872, I'll leave the change off. So I'll just say minus 10,872. We'll end up paying back $1,728 more in interest. So there's our interest. Loans, oh, it's crazy. All right. Excellent. Okay. Next one. If you buy a computer from the manufacturer for $3,500 and agree to repay it in 60 equal installments at 1.75% interest per month on the unpaid balance, how much are your monthly payments? How much total interest will be paid? Okay, so we're looking for payments, which means that, let me go look at the formula again. I'll write it here. One moment. So payment is equal to present value times I over 1 minus 1 plus I to the negative n. Okay, perfect. We got it. I'll come back here. All right. Now let's label everything we have. Present value means we're paying for the computer we just bought, which was $3,500. Okay. And then here, this one's already giving us I, and this one's already giving us N. So whenever you see 1.75, or just whenever you see the words interest per month, that means they're already giving us I. Because remember, I is rates over compounding. So this is a rate per month. So this means that I is already figured out for us at 0.0175. A little tricky there. And then this one is already giving us N. Well, we're going to repay it over how many installments? We're going to repay it over 60 installments. All right. Because you see how no years are actually given there, right? No years are actually given there. But if we're compounding monthly, because it's interest per month, you would do 60 divided 12, which means we are doing this for 5 years. Okay. So this one, a little bit different than the other ones. Okay. But we are now ready to plug in. So payment is equal to 3,500 times I, which is 0.0175 over 1 minus 1 plus 0.0175 raised to the negative 60. Raised to the negative 60. All right, so if we buy this computer for $3,500, what are our monthly payments? Let's find out. 3,500 times 0.0175 over 1 minus 1.0175. Raise it to the negative 60. Enter. We will be paying $94.69. Now, how much interest will be paid? Well, let's figure it out. We're paying $94.69 for 60 equal installments. So 94.69. And we're paying this 60 equal installments, which means that, oh boy, not good. Which means that you'll pay back 5681.4, which means subtract the original amount of the computer and 561.84 minus 3,500 will pay back $2,181.40 back in interest. Not good, especially when the computer was already $3,500. That's why we never make the minimum payment, people, right? All right. Okay. Cool. There it is. Interest. That's just gross. Okay. All right. Let's keep going. All right. One more. Let's see. So busy today. Okay. We want to purchase an automobile for $28,500. the dealer offers you 0% financing for 60 months or a $6,000 rebate. With the $6,000 rebate, you can obtain 6.2% financing for 60 months at the local bank. Which option should you choose? Okay, so, well, let's look at our payments, what our payments will be for these two options, right? So, let's go with option 1, right? So, option 1, all right? Let's say we go with the 0% financing. We're going with the 0% financing. Okay. So this means that our payment is just going to be $28,500, and if we choose this option, it's going to be $28,500 over 60, because they're going to split this up over 60 months. So let's see, what's 28,500 over 60? Which means if you choose this option, your payment will be $475 a month for 60 months with 0% financing. So there's option 1. Now let's look at option 2. Option 2, all right, we're looking for payment, which means we're going to need the payment formula, which is payment equals present value times I over 1 minus 1 plus I to the negative n. You see, once it burns in your brain, you remember it. Okay. Let's see. There you go. That's an I. All right. Well, let's list what we have. We're buying the car for $28,500. Actually, since this is a second option, we're not buying the car for $28,500 because we're taking the $6,000 rebate. So this means that we're actually buying the car for $22,500. But if we choose this option, we're going to get 6.2% financing for 60 months at the local bank. Okay, which means I is going to give us rate over compoundings, which means that we're going to get 0.062 over 12. Let's see, is that a nice number? Or is it just 0.062? We'll have to see when we check our answer. All right, 0.062 over 12, is that nice? No, it's not, so I'm gonna leave it like that. Okay, so we're leaving it like that. And then, this is saying that we're gonna do these payments for 60 months. So they're already giving us N. N is just 60. Okay, so we're gonna have to compare answers because, like I said, these can be tricky. Is it just 6.2 or is it 6.2 over 12? So I'll put or 0.62. And I'll check both answers. Don't worry, we'll see. All right, so we have everything we need. We can plug it into the formula above, which means we get payment equals 28,500 times I, which is 0.062 over 12 over 1 minus 1 plus 0.062 over 12 raised to the negative 60. And let's see. All right, so 28,500 times fraction 0.062 over 12 over 1 minus 1 plus fraction 0.062 over 12 and raise it to the negative 60. And with that being said, our answer is 553, which probably is incorrect, which means it's maybe 0.062. So let's check our work on that one. Because if we took off $6,000, then our payment should be less. So maybe that gives it away. So let's try it again. 28,500 times fraction, how about just 0.062 over 1 minus parentheses 1 plus, actually that'll just be 1.062 raised to the negative 60. Oh, never mind, I know what I did wrong. I typed in 20. I typed in 28 instead of 22. My bad. Well, let's see what happens with this. All right. See, it keeps increasing because I just messed it all up. Sorry. So here, we're going to fix this real fast. So looking at the problem, this should have been 22,500, not 28,500. That's my bad. Typo. Okay. Ooh, erase everything. All right, so again, we're going to try it. I'm going to say 22,500 times fraction 0.062 over 12 over 1 minus 1 plus fraction 0.062 over 12. Raise that to the negative 60. That's better. Okay, so this one we'll get a payment of $437 and 8 cents. $437 and 8 cents. And yes, I'm gonna double check it with the other one. So 22,500 times fraction 0.062 over 1 minus 1.062 raised to the negative 60. And I guess that solves it. When I type that in, I get 1433 as my payment, which means choosing 0.062 would be incorrect. So let me go back up here and change this. So we have our answer. Boom. So I should be 0.062 over 12. Okay. Awesome. See, that's why we're here. We can double check it. And of course, you're going to go to option 2. 1, you took $6,000 off. And 2, you get to finance at a local bank. And 3, it lowers your payment. Why not? Okay. Okay. Awesome. So let's keep moving. All right. Example 8. A time machine costs $80,000, coming soon in the near future, right? You pay 10% down and amortize the rest with equal monthly payments over a 7-year period. If you pay 9.25% compounded monthly, What is your monthly payment? How much interest will you pay? Okay, excellent. So again, this one is looking for payment, right? We're looking for monthly payment. So which means that, again, I'll write down the formula just to do it. The more you write it down, the more it burns in your brain. Payment is equal to, see, I already messed that up. Payment is equal to present value times I over 1 minus 1 plus I to the negative n. I over 1 minus 1 plus I to the negative n. Yep. Okay, now again, just label everything we have. All right, let's start with present value. So, present value. Well, it costs $80,000, but we're putting 10% down, right? We're putting 10% down already. So if you look over here in the calculator, I would do 80,000 times 0.10. This means we're putting $8,000 down, which means I would do 80,000 minus the 8,000, which means, whoops, 80,000 minus the 8,000, which would be $72,000. So that is the present value of our time machine. Or a faster way to do it, if you probably already thought of it, well, you could just do 80,000 times 0.9. And guess what that's going to give you? 72,000. Right? Okay. All right. Well, there's your present value. And now let's look for I. I is rate over compoundings. So we are doing 9.25%, so 0.0925. And we are compounding monthly, so over 12. I doubt that's a nice number. Let's see, 0.0925 divide 12. Nope, we leave it as is. Okay, which means we move on to N. And compoundings times time. We are compounding monthly, and we're doing this for 7 years. So that's 84. Okay. We can now type it in to the formula. Our payment for this time machine is going to be, let's see, we're going to get 72,000 times 0.0925 over 12 over 1 minus 1 plus 0.0925 over 12 raised to the negative 84. All right, perfect. Now, let's type it in our calculator. Okay, so 72,000 times, fraction again, 0.0925 over 12 over 1 minus parentheses 1 plus fraction 0.0925 over 12, move over, parentheses, raise it, negative 84. All right. And our monthly payments for this time machine will be 1167 and 57 cents. Okay, now we need to figure out interest. we are making 1,067.57 for 84 months. So multiply that by 84. So we will pay 98,075. I'll just leave those cents out, and we will subtract it from the amount, the present value, 72,000 minus 72,000, and we will pay $26,075 in interest. Gotta love it. Gotta love being a bank. If we could be our own bank, man, be so rich off of interest. So rich off of interest, and what's it called when your account goes in the negative and you get charged for it? I already forget the name. I'm blanking out. But we make money out of that too. So that'd be an evil bank, but yeah, that happens. Okay. Default, right? You default or whatever. Okay. All right, let's go. All right. Hey, oh, okay, it was like almost the last one. Okay. Number 9. Some friends tell you that they paid $35,118 down on a new house in order to pay $737 per month for 30 years. If interest is 5.1% compounded monthly, what was the selling price of the house? And how much interest will they pay in 30 years? Okay, excellent. So we want to know the present value of the house. So that's what we're going to find because they're giving us all the pieces. So again, let's write the present value formula in. So present value is given as payment times 1 minus 1 plus I to the negative n over I. Okay. And they say payment is $737. $737 per month. I, rate over compoundings. Our rate on the house is 5.1%. So 0.051 compounded monthly. Are you a nice number? 0.051 divide 12. 0.051 divide 12. You are. 0.00425. Perfect. All right. Now let's find n. N is compoundings times time, compounding monthly, and we're doing this for 30 years, which means that that is 360 months. How did 30 years become a standard for houses? Ugh. Or even worse, 360 months. 360 months of payments. Oof. Well, it's better than renting, maybe. I don't know. There's pros and cons everywhere. Okay, let's keep going. All right. So now we want present value. So we're going to say PV equals 737 times 1 minus 1 plus 0.00425. Raise that to the negative 360 over 0.00425. 0.0425. Okay, now let's see how much our house was. after the down payment, that is, times 1 minus 1.00425, raise it to the negative 360 over 0.00425. Enter. And the present value of this house is 135,739.99. Or let's round, which means that this will be 740. 135,740 bucks. But this was after down payment. So we need to add the down payment, which was $35,118 and so 135,740 plus 35,118, we get 170,858. So that was the original amount of the house. They put 35,000 down? Oh man. Aren't you only supposed to do 10%? Or maybe they put down 20%, right? Because if I did that times 0.2, yeah, 34, they put 20% down. Ain't nobody got 35,000 to put down in a house. Ooh, all right. You should though, so you don't have to pay PMI, private mortgage insurance. Oh, it's a waste of money. All right. If you don't know what private mortgage insurance is, look it up. So the reason you pay it is you default on your loan and you can't pay your mortgage anymore. The private mortgage insurance makes sure that the mortgage company still gets paid. Not you, the mortgage company. They have to protect their end because you didn't put, what was it, 20% down? So that sucks. But hey, it happens. But it also depends on the loan you choose. Okay, so be more well-informed on when you buy a house. What loan should you choose? Try to avoid the ones with PMI in them, because then over time, it's just a waste of money. So this is why you want to pay down your house a lot faster. If you do have PMI, once you pay it down to 80%, I believe, PMI cancels. Because the mortgage company's like, hey, they can pay their loan. Good, we've taken enough money from them. Ridiculous, I know. Okay, excellent. So that's how you work all those formulas, know what formulas to use, know how to use your calculator. The last page is just what formula goes with which problem. All right, so, and some sure can be debatable. You can be like, hey, I didn't agree with that answer. Well, good, you can talk to me during class. All right, 1, Johnny wants to invest $4,000. What is the better annual percentage yield? 8.1% compounded semi-annually or 7.7% compounded daily? What formula would you use for this? And since this just wants annual percentage yield, APY, the first one is going to be F. Okay. The company wishes to save $1 million in 5 years. How much money should be deposited each month, assuming the company will receive a rate of 5% compounded monthly? So they want to have $1 million in the future. So this is going to be future value, and they're also making deposits each month. So remember, future value and present value are based on payments every month, right? So this one, they want to have the money in the future, so this is going to be H. Okay. 3, Roberto makes a one-time investment of $8,000 at 2.5 compounded continuously. How much is the account after 12 years? Well, there's the key words, compounded continuously. This means this is going to be your best friend, PERT. So E for 3. 4, Candace is pre-approved for a 20-year mortgage of $165,000 at 4.875% interest compounded monthly. What is her monthly payment? We just did this. So she just bought a house. That is the present value, which means that's going to be I. We want to figure out her payments, present value. All right. 5, Josh repays a loan of $10,000 at the end of 10 months. What amount was repaid if the annual interest rate was 8.3%? All right. There are no compoundings in this one, so we don't see anything about compoundings. So this one's just going to be simple interest theorem. So this will be C. What amount was repaid? Okay. All right. 6, Wes wants to invest in his children's future. He decides to deposit $1,000 every 3 months in an account paying 4% compounded quarterly. How much will be in this account in 10 years? So he decides to deposit $1,000 every 3 months in an account. So he's putting a payment of $1,000 in every 3 months. So he wants to know how much will he have in the future. This has to be future value. So H. Okay. Callie wants to buy a new car. Her payments are $465 per month for 5 years. Her interest rate is 2.9% compounded monthly. What is the total amount of the loan? Her payments, her interest rate. So what is the present value of her loan? So again, that is I. Okay. There we go. That is it. That is amortization. Breathe it in, take it in, more formulas, but we are done. Okay.